In the precise nail, the rotational components are inside, which move the nail apart. It's the same with the fit bone, but there the field and anchor are deep inside. Here, only the rotational component is inside, and the magnetic field comes from outside. So it has been relocated. Here, one must make a very clear distinction, in principle, between the electric and magnetic nails and the mechanical ones. Here, we must talk about the force we need to accomplish the extension at all. And the force can be provided from within by bringing electrical components deep inside, which ultimately facilitate the separation of the bone parts. Then we are extremely reliant on miniaturization. We do not have arbitrarily large medullary cavities at depth in which we can fit everything. Accommodate dimensions. Unfortunately, that's not possible. We rely on very narrow medullary cavities. So the room for maneuver is very limited. If I have external fixators, then I can attach whatever I want in principle. With the monolateral fixators, I can attach unilateral, huge telescopes that attempt to move the bone apart. I can't do that here with the electronic systems. So miniaturization plays an enormous role there. And through miniaturization, in conjunction with stabilization, you'll surely talk about that later. We have to address two fields. We have to ensure stability, ideally so that the patient can fully bear weight immediately after the operation. He can't jump with it, he can't run with it, but he can walk accurately and carefully. He is allowed to do that, even for kilometers. But at the same time, we need to have strength in these internal systems for moving apart. And the strength is it's not trivial to incorporate it into the interior of a nail. If I build more inside now, I have to thin the outer wall. Then it is again not enough for stability. You have expanded it here. If I make the wall too thick, my motor becomes so small in diameter again. It doesn't deliver any torque and it stops. It doesn't have the strength to move apart. And that's why, in the end, we returned remorsefully from this group of nails. That was my beginning with Fitbone electrical nails. Control via phone through everything possible. Inquiries in the Far East or wherever in the world with reverse telemetry with everything possible. That has not been possible to achieve until today in this miniaturization, and that's why we returned remorsefully again. To mechanical nails, we once again engaged intensively with the truly ingenious principle of the Albizia nail, which was introduced by Cremont, a truly brilliant inventor, also in many other fields, a Frenchman. With the mechanical nails, we return once more to the development of force. If I have to generate the force from within, I am limited. If I generate the force from the outside, let's leave out the ISKD for now. But let's just go down this path. So whether it's Betzbonen, G-nail, G-she-nail, Albizia, and so on, we'll get to the details later. Then I use huge levers to ensure movement. You have to imagine there is a nail installed. Now I want to perform this rotation here to make the nail move apart. How can I do that? How can I do that easily? I take my lower leg. The lower leg is a huge lever producing an enormous torque. And with the lower leg, I move this nail very easily. The nail has inside it a thread with a stability that cannot be achieved by anything else. This is an 8mm thread, a metric thread, which cannot be stopped in its movement. And I turn this thread apart with this ratchet mechanism, similar to what was already used with Albizia.